let's go the extra mile. And that's something that you really can't do in like 90% of the applications that we write if we follow whatever you want to follow, MVC, MVVM, MVP, Viper, or whatever your mother said today. It doesn't matter, because none of those architectures have such a simple way of thinking about the state and the events. Okay, so again, this is what I'm going to show you now. I want to just show it to you to prove you that it's not magic, that it can be done just by getting the benefits of these simple concepts, which is what the architecture gives us. So what I'm talking about, it's time travel. Okay, so imagine that you have a system that you don't have to do anything, just because you're using and you're building your app in this nice way. You don't have to do anything at all, and for free you can actually time travel through the changes on your application. And by that I mean every time that you do something on your application, that's tracked on a history. And then with some fancy UI, what we're gonna do today is just a slider on the application itself. But you can go the extra mile and build an external application. And actually, somebody, I want to showcase it because it's quite cool. Somebody actually built this Historian, which, as you can see, is like it's an external application on your Mac, and it keeps track of everything that happens on your application. But not only that, it's like you can actually click on one of these points in time, and your application goes to that point in time. If that's not mind blowing, I don't know what else to do, to be honest. Because honestly, like how many things that will help with. I know this is not new. There are, like on web with Redux, of course, because it's the similar idea. They already do that, and it's super nice. So I'm super excited to actually have this available kind of for free into our world, into iOS. Okay, so imagine that QA is doing this. Like QA finds a bug and it just clicks a button, and instead of sending you, I don't know, the curl for the API, because it's always an API problem, of course, but sometimes it's not. Okay, maybe 1% of the time it's not. It's actually our problem. So imagine that when that happens, they can just not send you what is useful for the API, but they can actually send you, okay, this is then all the things I did. The steps to reproduce, I don't have to write them. Just send this. And you just need to load that. And you can actually just click next, and see every change that QA did, and you can actually see where the bug is just by debugging. What I want to prove to you, and I'm not sure how it's gonna go, is that we can code this in whatever time we have for today. We're gonna code here live, and if it works, cool. If it doesn't, well, let's cry a little bit together. But that's what we're gonna do today. Okay? So let's drink a little bit and see how that goes. Where should we start? So I guess the first thing I want is, as we said, like we need to hire the reducer that can basically hook into the actions that we send to our reducer and actually keep track of that and all that stuff. That's going to be the first part. And for the second part, which I'm not sure if it's going to be way harder or stupidly simple for what the use case that we have, is that we want that when you can go back in time, we just reset the state to that basically point in time. So for that, okay, well, let's see. Let's start coding. It's not useful to think a lot if you don't know what you're doing. So let's call this time travel because I like it. We could call it Doctor Who, but that's too much. So let's say that we want to import the composable architecture, and we want to import SwiftUI. Yeah, because I need to interact with SwiftUI, I think. Because the idea is that, yeah, because we need to put the slider, we need to show some UI for the time travel. So yeah, we need some UI. Okay. So then the next thing it's gonna be well, let's start by making the reducer. So let's do a reducer where, and this is one of the reasons why reducer it's put in a type instead of just a floating function, because you can now extend it and make a nice API for it. But again, as I said, just thinking about it, you just need to think about it as a function. That's it. There is nothing else. We need to return a reducer here. And this needs to be a reducer with the, let's use this snippet, because I want to write time travel a lot of times. So we're gonna have a state. Do I need an action? Well, yeah, because again, because we have UI, we need to have actions when that UI changes. The environment, I don't think we need it. Again, if you are making, for example, something that communicates with an external application or stuff like that, you're gonna need an environment for this. But for now, let's just pretend we don't need that. And here, yeah, it's a time travel state, the environment, and for the environment, well, I guess the well, yeah, no, sorry, I'm mistaken. We don't need this reducer because we're making or higher reducer as part of this, so we don't need that. Yeah, okay, makes sense. So yeah, for state, we have this state, and we have this travel action, and we have the environment of the reducer we are being called in. So yeah, this reducer, like for example, I think the debug reducer, and we can actually check debug. I think, yeah, this one. I think the debug, what is this? No. Reducer, I think the debug is here, right? Where is it? So I think, this debug reducer basically doesn't change the type of your reducer. So it's actually nice because you can put it, if you have a chain of these higher order reducers, you can put it anywhere and it doesn't affect anything else. In our case, as far as I know, I don't see a way of avoiding this right now. Maybe I realize something later, but I think we actually need to change the type of the reducer, because we're going to be putting that into our own view. So that's the idea. So what do we do here? Well, we just create a reducer again, as always, and here we're going to have the state, the action, and the environment. And we're going to return an effect. Okay, yeah, I think I can get rid of this. And if we make a mistake writing this, forget about any help from Xcode, because it freaks out. They were supposed to improve this, but I'm not sure there has been much changes, to be honest. But so that's the reducer we want. Okay, let's for now just fatal error here, because I'm still not sure how we're going to integrate this. So for now, let's just tell the compiler to shut up. So the part I'm not exactly sure how to do is how to integrate it on the view, because what I eventually want is, like, let's use the preview as an example. So what I want at the end of the day, it's kind of like a time travel view, and just to make it fancy, we can use like the SwiftUI style, and basically that's what I want. That's what I want. Okay, now from what I want to what I can do in live coding, it's a different story, but that's what I want. So well, let's just start with this, and let's see if we can actually do it. So that's going to be a view. That's going to be a view. So to have a view, basically, let's solve one problem first. I want to have the SwiftUI kind of DSL, and for that we need to use function builders, the SwiftUI function builders. For that, for that, I'm gonna use this because I don't remember exactly how to do them. Yeah, that's what I want. Okay, so I need a view builder. And this view builder is like, you don't have to super understand it. It's basically what the trick that SwiftUI uses to have the nice DSL, basically. And I want the escaping function that we give it something and it returns the content, no? Now this something is not gonna be a view store. Needs to be the store. Yeah, because we're wrapping the store, so we need to pass the store. Okay, so that means, well, I need the store for the time travel specific logic. So we can have the state, we can have the action, and the environment. I don't need my own environment, but I will need it for the type system. So let's make a generic for that. Yeah, I know, chill. Okay, do you want this? Let's make the compiler shut up. Okay. Yeah, so we need this environment here, right? Okay. So our view is gonna be generic. That's for sure. But now we're gonna need a lot of more generics, because one generic we need it's this one. So basically our child view, which is the real view that you are using, in our case this killer app view, needs to be this content. So as in there, basically content needs to be a view. Okay, so now this is happy. But still, what we need to pass here is a store. And here we need to give you the store that you are expecting, not the time travel store. We need to give you the store that you're expecting. So for that we need a lot more, basically we need the state and we need a generic action. And this store is gonna use your state, your action, and your environment. So I'm gonna give that to you so you can render. That's fine. Say what? Got 3, but yeah, because the store doesn't need this. Because that's part of the reducer, yeah. Initializer requires a oh, well, yeah, you're right. You require a body. So let's say that we actually need the same, like that. Is the stream still up? Yes. Okay, that's good. So here we just want to store the content. But now we need the store. And for that, let me see. Okay, so basically what we're saying here is that we're gonna receive a store. And this store is what we can pass here. That makes sense. But we need, I mean, the time travel view needs somehow to have all this to give you the store that you want. Otherwise we can just pass it in the initializer of the time travel view, right? It's like you initialize the time travel view with basically the store and the actions that your own view needs. Yeah, why not? Well, to be honest, let's just copy this. So the initial state is a state. The initial reducer it's well, it's basically the reducer that goes with your state, with your action and your environment. And the environment, it's gonna be your environment because the time travel doesn't need any. Okay, so now in theory we can just get this and pass it here. Yeah, we're not creating the store is being created for you. Now what? Well, now we need to make this a store. The comparison, it's gonna complain, right? Yeah. Okay, now it's the tricky part. Well, I'm not sure how tricky it's gonna be. Because this store needs to be a time travel. Like a store with the state and actions from the time travel. But for that, I think we can just create a reducer. Not a reducer, sorry. Yeah, I don't know why I didn't write that. We can create the state with the initial state. But I need time travel state. Well. No, yeah, that's fine. Let's break it down to see what we need to do. So first of all, we need a store. Let's call it child store with state and action. And that's quite easy to create because we have all the data we need. Why? Oh yeah, sorry. Now we're talking. So yeah, now it matches this with this reducer and this environment. Okay, so yeah. So maybe we can just pass the store here instead of passing each thing separately. I don't think we need. Well, we can clean that up later. But now that we have this, we need to convert this into a time travel store, and for that we can use the reducer. No, because that's already. Yeah, no, I'm doing it wrong. I'm doing it wrong because what I need is actually, yeah, I'm being confused by the reducer and the store. That's what's happening. That is what's happening. So the environment, I don't care about the environment, so you guys just pass it around. The state, we need to create this state. But of course, that's, yeah, I forgot. Yeah, okay. So the state needs to be generic. Child state, let's say. And this needs to be basically, well, I guess we have the current state, which is the child state. So we can say current, it's basically what you're giving me here, which is the initial one. Okay, and the reducer now, it's one. You use the reducer and you call the time travel to get that reducer. Okay. Yeah, and now this is generic and it needs to be generic over this state. Okay. And to be honest, we will need the same for the action. Oh, you can do this. Yeah, I'm pretty sure you can, but I'm not doing something correctly. Yeah. Like it tells you, oh, I cannot resolve this, but it's because there are errors somewhere else. So yeah, it needs to be equatable. So we can force your child state to be equatable. That's fine. And now we need to say this state actually needs to be equatable to. So basically putting the pieces of the types puzzle together. What just the complete? Yes, state, because it's the local state from here, so we can just do this where state is equatable. Okay, that's cool. That's cool. That's cool. Oh, maybe it's not that cool. Is it or not? Tell me. It is? Yes, it is. So stop complaining. Okay. So now we have the time travel store. Now let's try to fill this in. So I mean, well, first of all, let's try to just put the, well, to get the child be working, we just need to call self content, but we need to pass the store, and we don't have a store for the child, so we actually need to pass something here. So we have the time travel store, and we can, I guess we can what? We can scope. Yes. We can scope the state and the actions. Isn't it actions? I don't know. So basically what we're doing now is like we have this time travel store, okay? That it's like a global store, but we have a view that needs its own child store because we have a child view. So we need to scope our time travel. Scope is like you just take pieces of the state and pieces of the actions and you give it to the children. So that's what scope does. It's like you have a global that takes care of a lot of things, and this is basically the composition that we're talking about. Like imagine that you have multiple features and then you make one state that has all of them. When you want to give to the specific view it's a specific state and it's a specific actions, you need to scope into that. So that's what we're doing here. And to scope on the state, we need to put the state somewhere, which we have, and the actions we need to do the same. So let's say children, child. And we need to do the same. I'm just gonna do it now because I know. Okay, and now we need to do a dance again. So this needs to be action, and action needs to be equatable, and it needs to be action, and action needs to be equatable. Okay, so now I have something to scope because like if I don't have the child action and the child state on my time travel states and action, there is no way that I can implement in the scope. So it needs to be there one way or the other. So now that I have this, I can time travel state the current, so that's gonna be that focus in there. And for the actions, which I think I don't know if it's actions or actions. So for that we also need the time travel action, and please use the child. Okay, I'm creating the view and I'm giving you a store scoped to the current and the child state, which are based on the generic types, is basically what you need. So that I think that should work. It shouldn't do anything yet, but it should work. Well, except this fatal error, it's not going to do anything. I mean, that should work, no? I have the feeling that, I mean, we should see the same. Perfect. So I'm excited because it means that we matched all the types We even use the fancy view builders from SwiftUI, so you can basically nest here whatever you want, like you can do with normal SwiftUI. And we just need to actually implement the time travel functionality, which I think that's not going to be that hard, but we'll see. So the first thing we need to do, as I said before, is keep track of things. And for that, we can make a history here that it's basically going to be an array of child states. And let's start with an empty child state. And then here, we need to basically do a kind of similar dance like the debug reducer does on the library, that debug reducer I showed you before. So let's switch on the action like any normal reducer basically. And now let's implement the case child action. So now basically we know that this action is for your view. It's not for the time travel because we will need more actions for the time travel. So this action is for the time travel. So we need to call is basically your reducer, and your reducer is self because we're an extension. Because we're an extension on self. So we can just call this because it's implementing the new callable types feature on Swift 5.2 if I'm not mistaken, I think. So you can actually use that if you are running on Swift 5.2. If you don't know what I'm talking about, there is a video on my YouTube channel about that and it's quite fancy. So now we need to use your actions. I'm gonna give you the child action. And the environment, it's always the same. Like I just keep passing the environment around because for the time travel, the environment is useless. Okay, and now it gives me effects. Well, it's actually one effect. Yeah, I know. Chill, I still haven't finished. So now your state is mutated here, so I guess I can just get my state, access the history, and append state current, right? So basically we're keeping track of the new state in there. And we need to return the effect. So if you want us to do something, we just give it to the action never to return type. Well, yeah. Well, no, that makes sense because this effect is from your action domain. I need to convert it into my action domain. So I think there is a map, and that's quite simple because we need to use this. So when your effect completes, it's gonna have an action from your domain. I just need to embed it into my domain, which is basically doing this embedding, and then I'm gonna receive it. I'm gonna fall into this case, I'm gonna extract it and give it back to you. So it's like for you nothing happened, but I kept track of it. So that's cool, and I think that should work. And to try this, we can just first show how many states are we keeping track of. So for that, let's make some little more fancy UI. No, not on a slider. Slider is gonna be for later. So we can just say I need access to the data, so I need to make with view store. That's a nice thing about the architecture. Like a week ago, this with view store was not like, well, a week and a half or something ago, that was not part of architecture. That was introduced quite recently. But because it makes sense once you understand it, and it's just like like you just need to repeat the same thing over and over. Like these small details, they just like get into your brain, and basically it's kind of mechanical. So what I want is the history count. And that should, okay, so we have two states. Yeah, the initial, and because it loaded on the screen with, yeah, we fetched the all applications and we are showing that. So we mutated the state 2 times. If I remove this, we're mutating the state 3 times. Okay, so we had 3 snapshots of our entire application state in memory now. So now we just need to make that you can actually go back in time. So let's continue with this. I already forgot what it was. Yeah, we are showing the story and we want to put a way to go back in time. Okay. So to go back in time, we're gonna put a slider, I guess is the easiest way. I think we could put like a stepper, like next, back, but I just put a slider for now. I think it's faster, to be honest. No, I'm not sure, I'm debating. I just want to do whatever it's quicker for the stream, you know. And to be honest, I think the stepper on macOS it's quite ugly, I think, by default. So the slider needs a value, and that's already a problem. Because we could keep basically here a state with an index. Well, that's cool, because that shows another thing about the architecture. If you have built a slider on SwiftUI, you basically, you know, you have, I mean, you can do a double and you say 0, and then you basically, you have this state here, and that it's internal to your view, and this state is gonna make sure that when it changes, it renders the view and all that fancy stuff. And then what the slider wants is it wants a binding to basically to a variable, and you get a binding from a state by using basically the property wrapper wrap value and that fancy thing and all that stuff. But what's the problem? That means that your state it's no longer on your state as it should be. So if you do this, the architecture doesn't know anything about it. You cannot test it. You cannot ensure that you change it from a specific place, and that's bad news. So what we actually need to do is keep this state in our time travel state. Okay, so we need to keep an index here, and I want to make an index integer so I don't have to deal with conversions at this point. And just for the sake of it, let's start at -1. I mean, this is not super nice, but it's gonna work. So that's the first thing you need to do, because you want to keep track of that somewhere, and that somewhere it's always your state. The second thing you need to do is, well, when the slider moves, it will try to change some data, but we don't change data directly on the composable architecture. What we do is we actually send an action. So we actually need to put an action that, let's call it change index, and we receive, I will say, I mean, in theory we want an index, but let's just for simplicity say a double, because the slider, at least as far as I know, it uses a double. So that's good. Now we have another case here, which is change index, and let's just break for now, just so the compiler is happy with that part. Yeah, that's fine. And now one of these nice things about having the architecture having your back, which is you can use the view store to actually extract a binding, from the state and from the actions. Okay, and let me quickly open. Well, I guess I can do. I want this. There we go. So the get, we're creating a binding now. It's gonna get word state, and we can pass the index. And I think What? Undeclared get? Oh yes, sorry. But it wants a double, so let's convert it now because otherwise the errors are gonna be insane. And then we need the set. But I don't want, yeah, I want the send. That's what I was reading here, which is the we're creating a binding. That's, and if you follow me on Twitter, you will like a while ago, like some weeks ago, maybe months by now, I basically implemented this myself on the Composable Architecture, but on the version they have on the episode sample code, and I didn't know how to call it, and I posted a tweet. And everybody had a different view of how to call these parameters. So yeah, so they at the end of the day they implemented the same functionality, but they gave them, I guess, what makes more sense in terms of naming. And send, I think there are some overloads. Yeah, see, we can just pass an action. So for that we can use the time travel action, change index. And that's it. Okay. And if I'm not mistaken, the slider has more stuff on the initializer. Yeah, it has tons of things. But it has a view builder for a label. Okay. So we can actually do put view store, we can show the current index of the count, but the index is 0 based, so that should be that, and this count is +1, so I think we need to, I'm not sure if I'm doing this right. Don't math in public, but yeah, anyway, we can just run it and see how it goes. And I probably want some padding. And again, like if you wanted to do this as a library, like to ship it and to actually make it nice, you will make a nicer view than this, and probably like hiding by default that you can just tap on the screen, some like Flex does. And then it shows up and stuff like that. But for simplicity, and we're just live coding this, so I don't want to complicate it. It's already complex. It's not super complex, but it's going well for now. But I don't want to say that we're gonna finish, because maybe I can figure out the last step. But for now, it's good. So I don't want to complicate it more. So I don't know why I moved away. I want to see. Because I want to put a limit, I don't want to put a 0 to 1. I think the SwiftUI slider can tell you, can actually have a range. Yeah, the bounds. But wasn't that something else? There was a slider. In, yeah, see, that's the one, Yeah, I want this one. Okay, so I can just use in and a close range of a floating point, so it needs to be a double. So I can just put in here. So you want to go from, I guess, 0, the close range, so I need to use this, and then I need to go from view store history count, but that's gonna be an integer, so I need to make a double. That should compile. It does? Nice. It doesn't. Well, but it's not complaining about here, so that's good. If it complains here, like the errors in SwiftUI are still not that nice. So yeah, I will freak out a little bit. But where is the error? Missing return. Well, yeah. Okay, so basically now we have the view part set up. We are getting a binding from the view store. So basically that's it's really nice because it lets you mix the like SwiftUI, which needs bindings because it basically a UI framework that requires like a two-way bindings, which is something we don't want because we just want to get the data and then feed actions back. It's like a unidirectional flow. So it's like two different ways of thinking. But with this view store binding, we basically bridge the gap between the two, which is again like super nice to work with. So now we just need to implement this. And that's something that probably is tricky. So now we're being told, okay, I want you to go back to this basically index, which is a state that we kept on our history. So first we need to change the index of this, otherwise it's gonna complain. Oh yeah, state, sorry. Because we are gonna be trying to move the slider, and if we don't update the data, it's not gonna be in sync. So that's very bad. And we can just use int. Again, we may be like in theory the slider should go in steps, so it should be fine. But now, okay, so we have the history at that index. So that's basically the snapshot of the state that we want to recover. Well, in theory, isn't it as easy as just saying current equals this? We're changing our current, and because current it's what we are giving to our child view, that should work. That should work. Doesn't it? Compiles, let's see. Okay, so we have this from 0 to 1. Okay. Well, it crashed, but we saw it moving, so that's good. Okay, let me review this. Well, yeah, one stupid thing we're not doing is like we need to actually increase the index here, because we're automatically, like, when there is a change, we're going to the next state, so we need to keep track of that. The problem is that we're gonna have to fix something here, because, well, I'm gonna show you in a bit. Well, yeah, the first problem I saw was that we were saying we were going too far. So that's this. And let me run because I don't know what else. And I think this count is wrong because we actually want the count because we want the total. So yeah, so that doesn't make sense. So I think visually this makes more sense. Okay. Now what did it crash? To be honest, I'm already showing you like the time travel implementation was done already. Now we're just messing with indexes that I basically did wrong at some point. So we can go back to the initial. There we go. That's how the app starts, and then we load data and we see the data. I don't understand is because why it goes there. That's because the slider yeah, this needs to be. We're starting at 0. I mean, I guess we can start at 1. No, because the array is 0 indexed, so this makes more sense. Yeah, because in the beginning there is, okay, so let's give me the maximum between 0 and this. Because you cannot reverse ranges in Swift. If you reverse a range, that's a crash at runtime. And this one is wrong because we have two states, so I need to get rid of this. It's funny how the complex things with time travel and all that stuff, it was not that hard to do, and now I'm wasting time just managing index. But now it looks okay. So we are at 2 of 2 because we loaded from the environment. We can go back in time and we can go forward. How cool is that, mate? How cool is that? Now we can just keep adding. So now we are here and now we're here, but now we can go back in time. So what? When did we start? At 1 hour of the stream. What took us 40 minutes to basically implement from scratch time travel for the application. And that's not because I'm too good, that's because the architecture makes it super easy. Super easy. That's great. One thing I'm wondering, and now it's like just like making it nicer because for the sake of it, it's if I'm here and I do this, yeah, that's wrong. That is wrong because we are rewriting history, so we need to clean the, yeah, like there is a step that it's in the wrong position. And you could implement here a branching system so you could see all the, but yeah, let's not go crazy, although that would be freaking cool. But I guess that for now we can just check if, so when we're modifying when we're modifying the state, we need to check if we're actually in one of these time travels. So I guess we can do that with checking the, like if the history count, so if the count is bigger than the index we are in, I guess. And again, maybe -1 because this. And then in theory, oh man, why is auto-completion not? Do you think I know from memory the entire array API? Or collection API? Let's go here. Hi Maria. Hi Salud. Remove subrange with a bounce. So remove subrange. So what do we want? I guess we want state index until the end, no? So the idea is like we receive an event, so we modify it. So before we add it, yes, that's fine. We need to basically remove. So we're in this index, we need to get rid of all of that because we're going to be adding a new one. I think that's all right. The two states of every programmer. I know exactly what I'm doing. I have no idea what I'm doing exactly. Like there is no middle ground in there, or one or the other. And I thought the hard part was the time travel, and apparently I did that quite quickly, and now the indexes, I'm broken. Okay, so boom 3, boom 4. Now let's go back in time, and let's go here and remove this. Bam. And we have only 2. Now we can, yeah, we lost the other, which is fine. Okay, so that's it. Boom! Boom! In your face! Time travel implemented. 40 minutes. Easy. Well, 45. Because I lost time with the indexes. Like, don't take that into account. And again, that's just because the architecture makes it really nice.